So Newton has this. He has the force of gravity, and he knows that it's mass 1, mass 2. They contribute to the value, and divided by the radius squared. But from our estimate before, we found out that that was just way too big. So what Newton did is he just did what everybody does if they make a mistake, they can't get the right answer. He made something up, and he put this value of big G in here. And this is the gravitational constant. And he really didn't even know what that value would be. He just knew that it had to be something really small so that when he multiplied by the masses and the radius squared, it would give you the actual gravitational force. So what we have now is our equation to solve for the gravitational force. Remember, we could have used little m, little g, but if we don't know little g, we have to use the bigger force here. So this is gravitational constant times the two masses. And then remember, this r is the distance between the centers of the two objects. The value of the gravitational constant, and we'll use this one a lot, is 6.67 times 10 to the minus 11. Remember, I said it had to be something really small. Remember, minus exponents mean there's zeros, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we shift that 11, 6, 6, 7. So that's a very small value that we would use for the gravitational constant. So let's look at an example here. We want to calculate the force of gravity between two masses. The first mass is 3 times 10 to the 26 kilograms. The second mass, 8 times 10 to the 19 kilograms. And the distance between their two centers is 4 times 10 to the 8th meters. You'll notice that we're using these exponents, so it's not just using the equation, but then being able to put all this into your calculator that may be a little difficult. So the force of gravity is big G, m1, m2, divided by the distance between them squared. So the force of gravity is big G. Remember that that is 6.67 times 10 to the minus 11. And we multiply that by m1, which is 3 times 10 to the 26th, and m2, which is 8 times 10 to the 19th, all over the distance between them squared, which is 4 times 10 to the 8th squared. So to calculate the force of gravity. So when you do this, I'm going to write down what you would write on your calculator to get you to practice this. 6.67. And if you don't use the EE button, use that because that's the times 10 to the. And then all you have to do is put in the negative sign. Don't use the minus, but negative sign 11. And then hit your times button. And then you can do 3, and then EE, and then 26. And then do your times button again, and 8, and then hit your EE button, and then 19. And that'll take care of the numerator. And then again, to square with these exponents, I always have trouble. So what I like to do is just do divided by 4 EE 8. And remember, squared means it happens twice. So I would do divided by 4 EE 8 again, and then hit your equal sign. And if you do all that correctly for this problem, you should get 1 times 10 to the 19. Remember, units for force are newtons. So the gravitational force would be 1 times 10 to the 19 newtons between these two objects if they're that distance apart. So I'd like some final feedback here. What happens to the gravitational force between two objects if there's more mass? What happens if they're further apart? Then to practice a little calculation, we give you two masses and the distance between them. And I'd like to know what the gravitational force is. And then also give me just a little feedback about some things helpful, confusing, or questions that you have. Hope this video was helpful.